Our season started with a 4 a.m. game reveal at the Wollongong kickoff. After everyone had a chance to read the rules and review the field tour videos, we started our strategy discussion. We first talked about what our robot needs to accomplish. This started with a points analysis, taking into account both normal scoring as well as ranking points.
Interesting points for your team to consider would be the different scoring positions for the coral on your reef. So for example, in L1, it's going to be the lowest and thus the easiest, but it's going to be worth the least amount of points. Whereas L2 and 3, you may need to remove some, if not all, of the algae to score. L3 in particular is also worth extra points in auto, so 2 versus an extra 2 versus the 1 and 2 in L1. And L4 is not blocked by algae, but is highest up. Another point would be the algae processing versus shooting into the net. Processing is worth 6, but if the human player scores it into the net, then it'll be only worth 2 for your team. Whereas if you shoot it into your net, it will be worth 4. But once the net starts to fill up, the processor will be worth 6 points rather than just 2. Defending this year is also very simple, as blocking one of the other team's feeder stations or coral stations will stop the other team from using that one, and thus lowering their cycle time overall, as they'll have to be crowded around the single coral station at the other end.
Then we talked about how the robot will accomplish each of our objectives. This process was spread out over the course of the first day because there were lots of geometry that we needed to investigate before deciding on anything. We first looked at ways to control how we outtake the coral once we get it in from the human player station, tested intake compression requirements, and then figured out dimensions in CAD. This year we chose to build 2 robots. Robot 1 will explore methods of cycling both game pieces in the most efficient way possible.
Our design focuses on minimizing cycle time by scoring both scoring elements with one procedure. When we're grabbing the algae, we want to be able to take it out and then be in the correct position to deliver a coral. And so we'd achieve this with some sort of pivot and have it so as it pivots up, by correcting the geometry, it moves it out of the way and then is already aligned at the 35-degree angle. And so while the intake is in the stowed position or within frame perimeter, there's some sort of delivery chute or mechanism to get it into the scoring mechanism. And in the actual design of the end effector, the spacing between the center of the ball or of the algae and the center of the coral will be exactly matched, so you can just drive to the center of the reef and it will already be offset the correct amount. So the driving is simplified, so you just drive directly at the reef by using the April tag, for example, and you'll be correctly lined up.
Meanwhile, Robot 2 will target the strategy we think will best benefit rookies.
The goal of Robot 2 is to provide an accessible design to teams with less resources while still remaining competitive. The robot is a low-profile arm bot that can pick up both game pieces from the floor. It can score L1 on the reef, and it can also score in the algae processor. Finally, for the end game, it can complete the deep climb, which is really important towards both the RP for climbing and RP for autonomous.
So a lot of Robots 2 strategy is around getting the algae into the processor, and as we know, a lot of these pieces start on the reef itself. So today, a large part of what we did was trying to figure out how we could get the algae from the reef onto the ground in the most efficient and simple way. And so kind of what we designed was a bit of a system where we have 2 tubes connected by on a hinge by a motor. And what we would have is that we would have it the robot come over here and kind of knock it over as it moved out. As part of creating this design, we also thought about how we could best score points during the autonomous period. And we realized that because we would be preloaded with the coral, the angle of our arm meant that we could have it angled downwards so that it would slide on. So as part of the prototyping process, the 2 main things we had to figure out was what height we wanted this tube to be, as well as what length we wanted this tube over here to be. So we knew that this height was constrained by the maximum starting height parameter of the robot. And kind of from there, we figured out what angle we needed this tube to be so that the coral could slide in while still being able to push these pieces of algae from between the second and the third to the third and the fourth level off onto the ground.
Today, most of us escaped the CAD grind and started building some designs, assembled the SDS elevator kit from AndyMark, built the field, and tested the climb. Instead of walking you through each of the things we did, here's a collection of clips from our day.
Kieran, what are you working on?
I'm currently building the algae claw for our algae/coral robot, the first robot we're building. And yeah, we'll see if it can grip the algae effectively off the reef.
Hey Peter, what are you working on?
I'm bolting into a motor. It's very sad because there's like 4 M4 bolts in the building remaining, and I have 3 of them in my hands.
Hey Tyler, what are you working on?
I'm working on an intake for the sea robot.
Hey Lewin, what are you working on?
I'm currently trying.
Hey Lewin, what are you working on?
I'm currently doing.
Doing great,
Hey Lewin, what are you working on?
I'm currently trying to finish up the elevator CAD so that we can get some plates custom machined. Hopefully, it'll be done soon because we kind of need to get moving on assembly. Thank you all so much for your support and watching this video. Don't forget to like and subscribe, and look out for our reveal video at the end of day 3.